Alrighty, welcome back. So we should have had our point plotted at 7, 8, 9, 10, 11. So it's kind of up here. I know it's kind of a little bit of a struggle, but it's fine. And there's actually some of you who may be saying, well, Ms. Sherman, like you don't even really need to plot that graph. Because if you think back to what we did before, right, then you would see that realistically, we know just from the fact that our, ooh, that's real bad. Okay. We can see that from our thing, our slopes are different, which means it is automatically one solution. All right. Then for the last part of this, if you ever have an x equals something, right? Y equals was a number, like through that number on the y-axis, and then there was that no slope, right? This is going to be through this number, but it's going to be on the x-axis. And this is where that undefined line comes into place. Remember how we talked about undefined? That's where this comes back. So if you look at these two lines, you would know that they are parallel, so they have no solution. They will never intersect. Never! All right. So now what I want you to notice is that our next part looks a little wonky. And so I just want you to realize that we are going to start kind of putting in points. That way, if our equation isn't written in slope-intercept form, we can make it kind of easier for our lives. Okay? So I know I gave you the table. And that's great. And so you can either use that to solve this, or we can plug it in here. I'm going to plug it in here first, and then we'll kind of check with our points. So I'm going to say M is 1/2, B is 3. So 1, 2, 3, and then up 1 over 2. And then grab my point. But then I actually kind of want to put in, because this will be kind of a nice check. I want to put in and see, do we get the same answers? Because we should, right? So if I were to plug in -1, right? If I were to plug in -1, I did not think that through, but that's okay. Then I have 1/2 times -1 plus 3. So that's -1/2 plus 3, which is 2.5 or 2.5, right? So at -1, we're at 2.5. Does that make sense? How we do that? So if I plug in 0, doing the same thing, 0 plus 3, well, that's 3. We did get that point, right? So that's kind of what we're doing. Now, this is going to be a little bit harder. We're going to plug in the same point. So I have -3. This is only x. This is not y. So now you need to solve for y. So I have -3 times 1, which is +3, plus 6y equals 18, minus 3 on both sides. 6y equals 15, divided by 6, y equals 2.5, which is not helpful because it's not a whole number, but that's okay. So if I do the same thing here, right, I have -3, and then I plug in 0, plus 6y equals 18. Well, that's 0, so I have 6y equals 18. Divide by 6, and y equals 3. So this one is actually 0, 3 as well. Kind of convenient. Plugging in, I'm going to plug in 1, I guess. did not think of good numbers for this, but that's okay. Okay, last one is the number 2. So then this would be, oh, sorry, this was 3.5. And then this is 4. Okay, so we have the point 2, 4. So if we connect those points, sorry. Do you see how these are the same line? So again, this is where we get our infinitely many solutions. Infinitely many solutions. Okay? So that's what we're looking at